Okay, so we're going to start with example 1, which is the integral. We're doing indefinite integrals for right now of x squared plus 1 squared times 2x dx. Now, before substitution or integration by substitution, we would have had to multiply this out and then distribute this to x. But because of this method, we are able to just integrate this right away. So we use u substitution, and most schools teach u substitution. You could use any variable though. So what you're going to do is, usually we work from the inside out, and we're going to let the most, I'm going to say complicated or inside part be your u. So we're going to let u be x squared plus 1. Now, to get du, remember our notation here. Du means we're going to differentiate u. So we're going to take the derivative of u. So we get 2x dx. Now, our goal here is that we want to get, at least with the variables, we want to get what we have in our integral. So see how we had a 2x here? We wanted to get a 2x here and then dx. So now we're going to substitute what we have back into our integral. So we have u is x squared plus 1. So our new integral is u squared, because it was x squared plus 1 squared. Our du is 2x dx. Well, look, 2x dx. So now instead of integrating x squared plus 1 quantity squared 2x dx, we're just integrating u squared du with respect to u. So now we're just integrating something with respect to a different variable instead of integrating something much more complicated. Now it becomes our simple power rule. So we add 1 to the exponent and divide by the new exponent. This is indefinite, so don't forget to add the c. So we have 1/3 u cubed plus c. Now the last thing we have to do is sub our u back in for our final answer, because our original problem was not in terms of u, it was in terms of x. So we want to sub this back in for u. So our final answer is 1/3 x squared plus 1 cubed, and then don't forget the plus c. Okay, so the biggest challenge is really figuring out what u needs to be. Once you get it all subbed in, it's just like taking a normal integral. So let's try a new one. Remember, you can pause me if you're not done. All right, so pause and try this one. If we have 2x times x squared plus 1 to the 4th dx. So if we wouldn't know about u sub, this one would really be terrible to do, because we would have to take this to the 4th power and then distribute a 2x, which would take a long time. So instead, we're going to let u be x squared plus 1. And then du, we're going to integrate x, or we're going to differentiate x squared plus 1. So that's going to be 2x dx. So this actually works out quite well, because we've got a 2x dx So that is going to be where we plug in our du. And then we've got our u to substitute for the x squared plus 1. So we've got u to the 4th du. Now this is an integral that we can very easily do. So we add 1, divide by the new exponent. It's indefinite, so we add c. So we've got 1/5 u to the 5th plus c. Okay, now u to the 5th, we don't want u, we want this in terms of x. So we are going to sub back in our x squared plus 1 to the 5th plus c. And that is our final answer. Okay. So again, if I'm going too fast, you can always pause me. It's just a video. It's not like we're in class real time. All right, here's letter B in the notes. So we've got 3x squared times the square root of x cubed plus 1 dx. So we always want what's on the inside. Remember, we would always rewrite square roots as powers to the 1/2. So I think our u should definitely be x cubed plus 1. Okay? Now, our du then would be 3x squared dx, which works out really well because here we have a 3x squared dx. So when we plug in or when we sub, we would have u to the 1/2 du, which even though it's to the 1/2, we can still pretty easily integrate that. So u to the 1/2 plus 1 divided by 3/2. That would be 2/3 u to the 3/2 plus c. Now, all we have to do is plug in x cubed plus 1 for u. So we have 2/3 times x cubed plus 1 to the 3/2 plus c. So nothing too hard. Okay, and then I'm going to end the first video there before we get to the trig ones. And then I'll come right back at you with a new video.